So today we will start with one basic question, and the reason I haven't put it over here because I want it to be a free flow. So the thing is, uh, and we will start with this again with some normal, like your day-to-day scenario or the issue which you are going to face in your day-to-day life is like you have an instance in something called you have a EC2 instance in private subnet, okay, and that wants to talk to a bucket, S3 bucket, and that is a private bucket too. Okay. How can we achieve this? Okay. Uh, Let me repeat this question. So we have a EC2 instance which is present in the private subnet, and we have a S3 bucket which is also a private bucket. So if I gave you the scenario that you need to implement it, from where you are going to start it? And before going to the scenario, anyone know what? Okay, let's start with, are you guys comfortable with what is VPC? And once we are done with that, anyone know what is the difference between a private versus a public subnet? Okay, let's first start with the VPC and then we will focus on private versus public subnet. So just a quick reminder, or just like what Mohit said, VPC stands for Virtual Private Cloud. Okay. So basically, if you think of any environment, right? Uh, Whatever company you guys are working, you might have a dev environment, right? And then you have a non-production, and then you have a production environment, right? Uh, the way these environments are laid out, or the way these are environment are separated, is with the network boundaries, right? So dev, we can say it's a kind of a free-flowing environment, right? Where uh, your developers, they are writing a code, they are pushing their changes, they are testing it, all those things, right? And once they're satisfied that the changes they are working fine as expected, they are going to push these changes into a non-production environment, where your QA team will be involved, your product team will be involved, who is going to do the testing, right? So, and after that, once everything has been verified, those changes will be pushed to production. But not everyone should have the permission to push the changes to a production, right? There should be some separation. So first, I mean, it may be your security boundaries and everything, but the way they are going to separate it with the help of a network, right? So virtual private cloud, in the simple language, is your data center in cloud. So most probably for most of the companies, they have their different environment, maybe and maybe not, but they have a different environment in different geographical location. And the way they are segregated is with the help of this virtual private cloud. So I will show you in just a few minutes, but you just need to define something called a subnet range. And once you specify it, you are going to, or a CIDR range. And basically you just going to separate your network into different subnets. And that is how you are going to do it in using a virtual private cloud. Okay. Now the second question is, now we have the network, everything is available. We have something called a private subnet and something called a public subnet. Okay. And subnet is nothing but just a separation in terms of a network boundaries. Okay. You divided one main network into smaller network. So the reason we are breaking it into a small network, because we want to deploy a different application. So let's say I divided into a subnet one, and here my web servers are running. Then I divided into subnet two. Here my apps are running. Or in terms of AWS, I can divide into different availability zones. And the reason for that is because of the high availability, right? In case if one of my availability zone goes down, I should have my service running in some other availability zone. So I might have a web one which will be running here. Availability zone. So I might have my web one running over here, and the replica of it is running on the availability zone second. Okay. So if you look at the example of Oregon region, we have something called US West 2. So if you go to the management console, you will see something called US West 2. And then we have the different availability zone, for example, US West 2A. And think of it like a different data center in different geographical location. And those are like 100 miles apart. So this is how we are going to lay out our network. So, okay. So you have some basic idea about the AWS networking. Do anyone want to speak about like what is the difference between a private versus a public subnet? What makes a subnet private and what makes a subnet public? So, okay. So now Bhautik has mentioned something about gateway. Okay. So what do you guys think of? Okay, let's try to break down into a one simple layer also. What do you guys think of a gateway is? Forget about whatever the terms Bhautik use, like internet gateway or net gateway. If I tell you this word gateway, what do you understand by this term, gateway?
Gateway means actually to enter to any premises.
Mhm.
Uh, that is called as gateway. For example, in the in the state they have a toll, right? So while entering to another state, they have a toll. So that is a gateway for that for the state.
Yeah,
For the building, they have a common premises, and we need to enter. So that is for that one is the gateway. For home
exactly.
is our door is the like gateway. Yeah.
Yeah, that's what I want to see. Like, we can go with like a simple examples. Like, at your home, you have a gate, right? Anyone who needs to enter into your home is via that gate. Yeah, or you have a door. A door is a gateway through which anyone can enter or exit your house. So similar in the similar terms, in a case of a networking, we have a gateway, and in most of the cases, there is something called router, right? Your IP address, I mean, that's the first IP address which is assigned to a subnet. That will be the gateway IP address or the router IP address through which any packet can enters your network or leave the network. Okay. Now we understand what is a gateway. Now let's talk about the few terms which Bhautik has mentioned, like internet gateway. And then we have something called a network gateway or a NAT gateway. NAT stand for network address translation. Do anyone want to speak about like how internet gateway or the other term which is uses IGW or this NAT gateway works in case of AWS? So we understand that, okay, it's fine. Like any packets which need to leave or enters into our network, it will go either by the network gateway or the internet gateway. What is the difference between these two? Or in more specific term, if you want to explain like how a packet enters or leaves my AWS network using these gateway, how can I define? Okay. So before explaining to this NAT gateway or internet gateway, let's go back to our original question, the difference between a private versus a public subnet. Okay. Now, in the layman term or simplest of terms, let's say a private subnet is something which do not have any gateway attached to it. I mean, I'm just using a very broad term, but I will explain how we are going to connect the gateway to the private subnet. And public subnet is something which has a gateway connected to it. Okay. And that gateway will route the traffic to the outside world. Okay. So basically, public subnet means something whom a traffic is transferring to the outside world. So for example, if I have a EC2 instance and that EC2 instance can talk to something like google.com. Okay. Private subnet means this instance cannot talk to the outside world. And the use case for that, for example, you have a database, right? You have a RDS database, anything, MySQL, Oracle, anything that you don't want to expose it to the outside world. You just want for your own testing or for your own deployment or anything. So that you can make it as a part of a private subnet. Public subnet means your web server. You are deploying some application which you want your customer to have access to it. So that you are going to put it in a public subnet. Okay. Now, before I'm going to talk about all these public and private subnet in depth, let's try to understand like a life cycle of a packet inside your VPC. So basically, you have your EC2 instance, right? And our ultimate goal is that this can spoke to something like google.com, which is present on the internet. Let's say in a broader sense, or I will say it will, let's forget about google.com. We want anyone who can access this whatever we are going to host the application in this instance, anyone from the internet will be able to access it. At the same time, if this guy need to talk to something on the internet, he will be able to fetch it out. Okay. Now we have this EC2 instance, we have the application, right? Now forget about the gateway part. For an instance or for your machine, if it's need to talk to the something to the outside world, what do you guys think? What will be the first place from where it is going to transfer all those packets? So forget about EC2 instance. If I have this laptop needs to talk to the external world or anyone who needs to talk to this laptop. What do you think? Where is the first place where the network packet goes?
Security group.
Security groups. Don't think in terms of security group and everything. Just normal laptop if it's need to talk to the external world.
Ethernet.
Exactly. Ethernet. Yes, your network card. That's what I'm saying. Don't think too much broad. I know you guys are thinking about it all in terms of security groups and everything. And but basic thing is the network interface card, right? Where the packet first goes. This thing, something called in terms of AWS language, is called Elastic Network Adapter. Okay. Now, again, the question back to you guys, why do you think it's called an Elastic Network Adapter? And just a hint, just focus on this first part, Elastic. Similarly, if you look at all the AWS definition, for example, EC2, they said Elastic Compute Cloud. So why do you think it's called an Elastic in terms of network adapter or compute cloud?
It might be the scalable. That's the reason called as elastic. I'm not sure, but I'm just trying.
Yeah, you're correct, Bhautik. Yeah, exactly. So in terms of AWS, if you go to the higher instance family, so let's say I started with, I'm just giving an example, T2 Micro, which has 1 CPU and 1 GB of memory. So for this instance, the network bandwidth you are going to get is really less. The network bandwidth, I mean, this elastic network card, he might be able to process a lesser amount of a data. But if you go with a higher family of instance, like let's say I am using something called R6X32, this will provide me a higher network bandwidth, which is close to 200 GB. One network card, I think it supports 170 GB. So as your instance size grow, as you increasing the elasticity, the amount of data you can transfer it will increase. Okay, I'm just talking in terms of network card, and that is how the whole AWS work. You can do something called a horizontal scaling. As your load increases, you can increase the number of instances behind your load balancer or something called auto scaling. So forget about all these things. Elastic means you can increase or decrease the band, not decrease, but you can increase the bandwidth associated to that network card. Okay. So now we have gone to this EC2 instance. Our application is up and running. My packet reaching to the network card. Okay. Now it need to go somewhere, right? Maybe internet, maybe in my local network. Okay. And we are not talking in terms of security group and anything, right? We are not talking a firewall. Just think in terms of network. What is the next place where it will find it out? Okay, it need to go to local network, or either it need to go to the external world. So for example, let's say from this EC2 instance, I want to access google.com, wget query, or any kind of query. So what do you guys think? What will be the next place or next hop? It's called route table. So it reaches here. After that, it looked into inside the route table. Okay, where exactly the packet need to go. Okay, then it will reach to something, a hidden part, which is not visible to all of us. It's called router. Okay, this router is going to route a packet to either to something called internet gateway or net gateway, and then it will go to the external world. Okay, so this is how the flow works in case of any packet which is present in your AWS VPC or your any of your EC2 instance. First, it will go to the network interface card. Then it will go to the look at the route table. Okay, where it need to heads. Then we have this hidden component called router, which is going to route the packet. It's just going to take the packet and it will forward to the internet gateway. And internet gateway is going to forward to the whatever be the destination. Now let's look into depth of this internet gateway versus the net gateway. What is the difference between the two? Okay, so this is internet gateway. And then we have this network gateway. Just remember these two terms because they have been asked n number of times during the interview, the difference between the internet and net gateway. Okay, so internet gateway, as the name suggests, something to do with the internet. We are routing something to the external world. Okay, so again, came back to our same thing called public subnet versus the private subnet. Okay, so if you look at the any of the EC2 instance which is present in the public subnet, you have two type of IP associated with it. One is the private IP, and second one is called the public IP. Now, what is the difference between the two? So let me show you with the help of the AWS console. If I go to this EC2 instance, I have two of these running. And let me go to this my public instance. And if you are able to see it, there's something called this public IP, which is associated with it. And there's something called a private IP, which is associated with it. Okay. So private IP means the something which you can use within your intranet. So within my company, I can use this IP. But to the external world, so external world means to the internet. If I need to route my package, I need something called public IP. Okay. So AWS will give us all even I can give you private IP range. So somewhere they will give us that range. Site log. Yes. So in case of AWS VPC, you can use these three subnets to specify your private IP ranges. Now, the way that it's work, you guys have understand about this thing, right? EC2 instance, all these. So up till now, you understand that public subnet, the EC2 instance has both the private IP as well as the public IP. So the way these things work is that when a request, so let's say this EC2 instance wants to talk to the internet. So the request will come, and let's take the example of this one. So we have this IP 10 dot this one, and we have this IP 54.200.104.229. So the way this works is that when the request is made by the EC2 instance, it will take this IP 10.1.1335. It will go to the network interface card with the same IP. So now in the route table, it will see, okay, the request which is this instance is trying to make is either a local request or it's need to go to the internet. And the way this things work is that, let me go here, VPC, select the particular VPC, and you need to look something called a route table. So if you look at the route table, we have these routes defined. So basically, if any of the requests, so for example, for this VPC, I have used this range, subnet range. And like I mentioned earlier, you can use 10.0.0, 172 or 192.168 to define your private subnets. So if the request need to be for within that private subnet, it's just been routed locally within that network. So the request will go to this ENA, to the route table, and in the route table it's seen, okay, the request is within the network. So it will not forward to the internet gateway. But if the request is for the outside world to the internet, then it will look to the other route where we have this internet gateway attached to it. So what it is going to do, even at the internet gateway level, it's going to do something called a network address translation. So it is going to replace this IP, this private IP, with the public IP. And the reason for that, because you cannot route a private IP to the external world. So let's take example, you are working for XYZ company and you are using this network. There may be some ABC company in the world which is using the same IP address, right? So there will be an IP conflict. Whereas this public IP, it is unique to this particular instance. Okay. So when this request go to the external world via the internet gateway, it will go with this public IP. And this public IP will go get the request. And once it hits the internet gateway on the reverse path, it will again translate it back to this 10.1.3.135 IP. And you will be able to access your EC2 instance. Okay, I know it's a lot to digest. Any question? Okay, let me try to explain one last time. So basically you have a EC2 instance, which is in the public subnet. It has both the IPs, like private IP as well as the public IP. When the requests go to the Elastic Network Interface, till this point it will go with this private IP. It looks in the route table. Okay, in the route table, we have two routes. If it's destined for local something. So with local destination, I mean, if this EC2 instance wants to talk to some EC2 instance in the same VPC, it will look at this route table and it will just route the request locally. It will not go to the external world. But in case if the request need to go to the internet, then what this internet gateway will do is going to perform a translation. And translation means it's going to change the IP address from 10.1.3135 to the public IP of that instance. And using that, it is going to route to the internet. On the reverse path also, once the request going to hit your route to your network card, it is going to, or sorry, internet gateway, it is going to change the IP back from this 229 to 135. And that is how, because internally it only knows this private IP address. And that's why this IP address is going to, I mean, that is how this request goes back to the particular EC2. Okay. One thing to remember, like I mentioned yesterday, if you are going to shut down your EC2 instance, shut down, not reboot. I mentioned it clearly yesterday, when you perform a shutdown, what the hypervisor will do, and we have talked a lot about hypervisor yesterday. Hypervisor is going to release all the resources which is associated with that EC2 instance. So it is even going to release this public IP address also. So next time your EC2 instance boot up, it might came up with a new IP address because it is coming from a global pool of IP. The same thing which I mentioned, that to the external world, this global IP is unique. This private IP is not unique. Okay. So if you reboot your, if you shut down, stop and start your EC2 instance, it might get a new IP, new public IP. So the solution for that, if you want this IP to be a static, is something called elastic IP. That is a static IP which is assigned to your VPC. Okay. Now let's look at the other part of this equation called a NAT gateway. So private subnet, look at the second part, which is called a instance, which does not have any public IP associated with it, and it has only the private IP associated with it. Okay. Now a question for you guys. In this case, I have shown you that, okay, some level of translation is happening, right? Your internet gateway is changing this IP 10.1.3.1.35 to this guy. But in this case, in case of private instance, we only have the private IP. So what do you guys think the translation will happen? Like if this instance in private subnet, it wants to talk to something on the internet, how this instance is going to talk to the internet, or it will get the data. I mean, the simple cases, in many cases, you heard this example, this EC2 instance, we need to patch it. And in order to patch it, it need to go to like CentOS or Yum or Red Hat repositories and Yum repo. And it need to go to those Yum repo, get the package and install in this particular instance. So because this instance only have this private IP, what do you guys think, like how this whole thing is going to happen? And the hint is it is going to use a NAT gateway. In order to understand that, you need to understand one more thing, that when you create a NAT gateway, for example, let me try to create it. You need to select something called elastic IP, like I mentioned earlier. And this elastic IP is the public IP. Okay. So the way this will work is everything is the same, but the translation happen at the elastic IP level. At the NAT gateway level. So when the request from your EC2 instance, which is in the private subnet, go to the ENI, still have that private IP, it look at the route table, and the route table, now we have the special entry. So let me show you the route table of this private IP range. What happened? Oh. Okay. In that case, we need to add a new entry, and we say if the request need to route to the external world, it need to use something called a NAT gateway. Something like this. Okay. So again, your EC2 instance, application, network interface card, route table. Okay. But no translation is going to happen at the route table stage, after the route table stage. Sorry, at the internet gateway stage. That is going to happen at the NAT gateway. So your private IP, which is coming to this, is going to translate it to this NAT EIP, which we are going to assign. And then the request will be forwarded to the internet. What Bhautik has mentioned. So now my question for you guys, okay, in this case, we have defined this architecture, right? And anyone like this EC2 instance can talk to the external world. And in case of this private instance, this EC2 instance can now talk to the external world. In public IP range, even anyone from the external world can talk to this particular EC2 instance. So for example, in this EC2 instance, I hosted some website, and that website can be accessible to anyone in the internet. Now, my question is, can anyone from the outside can talk to this EC2 instance, which is going through this network address translation? So I'm in the reverse route. So if you as a user who is sitting on somewhere on the internet, you want to access this EC2 instance, which is on the private subnet, but it has a NAT gateway attached to it. Do you think you will be able to access this instance, or anyone in the world can be able to access this instance? Yeah, Mohit, that's correct. No, but do you know why?
Because the translate when the translate when the NAT gateway is translated, so they change the source IP of the inside the packet, so the and the packet is exposed over the internet as the IP of NAT gateway. So that is a public IP. So from the outside or over the internet, you can only reach out to the NAT gateway, but not behind the NAT gateway.
Okay, yeah, but okay, yeah. So let me try to explain it what Mohit has mentioned. So yeah, you have seen that here the translation is happening, where your private IP is converting to a public IP. And on the reverse route also, this translation is going to happen. So basically this is called SNet, which is called source net, when your private IP is converted to a public IP. And on the reverse path, it is called a destination net, when your public IP is converted to a private IP, which is perfectly fine, right? This is happening in case of when you have the public subnet. But if anyone from the outside world, if he's going to raise a request to using this public IP, which is the NAT IP, this NAT gateway IP, right? We know that NAT gateway perform a translation for this to some public IP of the NAT gateway. Okay. Up till this point, user hit this NAT gateway IP. After that, in this case, it knows that, okay, this translation happened, that it has this private IP, which is it is translating to public IP when the request is going outside from this EC2 instance. But on the reverse path, if someone from the internet is trying to access it, we have the public IP, but it does not have the private IP, right? Because the request is not initiated within from the EC2 instance. So it does not have, it do not know where to route that particular request. So what NAT gateway is going to do? It's just going to drop the request. So that's why we say it's a secure architecture where an instance which is behind the NAT gateway can talk to the external world, but anyone from the external world cannot talk to the EC2 instance. Did I confuse you guys, or is
No,
that
it's
clear?
it's a clear. It's clear for me. But it's like even if you want to allow from the public to private, it means option is not available in that case, right? Because we need to making sure that the network is like more secure. In that case, we are using the net gateway, correct?
Exactly. And I mean, if you want someone from the outside world to talk to your instance, in that case, you need to switch to internet gateway. That's the only option.
Okay, that's not the option. Okay.
Or in case if I want this EC2 instance, I'm using these terms broadly, but basically, all the networking, it is happening at the VPC layer, right? Whatever the network you are defining at the VPC level. So at the VPC layer, I want that this server can talk to the one specific website, for example, xyz.com, but it will drop the packet for the rest of the world, or vice versa. I will say this will drop the packet for this particular website, www.xyz.com, and for the rest of the world, it allows. Do you guys think it's possible? Whatever we have learned so far, internet gateway, NAT gateway. anyone know if it's doable or it's not doable at all?
With using the Net Gateway, you mean to say
No,
it's
I mean,
doable or
any of
not?
the AWS construct, can it be possible? Like, I want to design this scenario. Either this instance can only talk to xyz.com, or let's say, okay, let's try to broad this concept. We have this VPC, and any instance which comes as a part of this VPC can only talk to xyz.com and drop all the packets. If it's so, for example, if I try to talk to google.com or facebook.com, it's going to drop the packet, or it can drop the packet for this specific domain and it will allow the packet to all the other domains. Can it will be possible or not?
We might be, I'm not sure, but the security group
Using
might be have
NACL,
a
can we do this? Using NACL?
No, because the reason for that, because I can give you a simple example. Let's say this www.google.com, simple example, right? At the NACL level, you can only specify the subnet. Okay. Or at the security group level, you can only define the IP or the subnet. Think of the Google IP, which might be, let's say, 1.2.3.4. Okay. And similarly, at the security group level, you cannot drop the packet. By default, it is drop. You can only allow the packet. At the NACL level, you can allow or drop the packet. Okay. Coming back to the same scenario, currently the IP of this Google is 1.2.3.4. At the NACL level, you said, okay, let's drop this packet or let's allow this packet. Fine. But maybe in 1 second, even Google, behind google.com, you have like n number of servers running. And it also picks the IP from the global pool, right? You understand how large the Google is, right? So it might have like 100 IP assigned to it, which keep on constantly changing. So either you need a mechanism, I need to write a Lambda function, which constantly poll google.com, get that IP and update my NACL. So in that case, it's doable. And I'm just saying 100, it may be 1,000 or it may be 10,000. So yeah, you guys are heading in the right direction, but understand that NACL or security group, they only understand IP. They do not understand a domain like google.com or any domain. So can this be doable? Again, coming back to the scenario, I want to allow xyz.com or I don't want to allow xyz.com.
But you need to use on VPC layer only, not using the web or like web service. Web service, we can
Yes,
do it, right?
WAF, yes, we can do it at a WAF. Okay, just in the interest of time, AWS now have a solution called AWS Firewall. There you can define a domain that, okay, I want to drop this particular domain and allow all the rest of the packets. Or I want to only allow this particular domain. I want to allow rest of the world, but I want to drop this particular domain. So look for this solution called AWS Firewall. And even they have something called AWS Route 53 Firewall now, where you can do these things at the Route 53 level. I can give you the link where you can. I know we are diverting from the main topic, but okay, let's stop this topic here. If anyone wants to talk to me regarding this, just ping me offline. But I know we are way digressed from the main topic. So our main topic was, so I have an instance which is present on private subnet. So now we understand that private subnet, in order for private subnet to talk to the external world, it need to go via the Nat Gateway. And the question I asked is like, we have the S3 bucket, which is also on the private subnet. So now my question is, if I add the Nat Gateway to it, can my EC2 instance in the private subnet can talk to this S3 bucket, which is also private? Remember that part. There may be a one piece of a permission puzzle which is missing here. Do anyone know what it will be? Just to repeat a question, we have an instance on the private subnet which wants to talk to a bucket, which is also a private bucket. So how can this communication going to happen? So basically, if you think of like, you don't want everyone to connect to your S3 bucket, right? You have make it private, or you have the S3 bucket, which you want only a specific set of user who can talk to, or specific set of EC2 instance, which can talk to this particular S3 bucket. So there you need to set up some boundaries, right? Like who can list those bucket, who can access those bucket. And for that, you define something called IAM role. Okay. Now, I again pause here for a second, and I want to know your opinion. What do you guys think of IAM role? And again, like the way we are doing it on the last 3 weeks, how does it work? And let me put one more question: how this is and how these are different. I mean, what is the main advantage of using the IAM role?
So I would like to add here. So basically, IAM role is basically a more secure compared to access key secret key, because they use the backend STS service to basically rotate the credentials for a certain period of a certain session. So that is more secure compared to other method of access, and it very similar kind of a service account that is you can associate with basically application or services. They can use the AWS services or authorization you can assign to particular service or application using this IAM role. So although they have other kind of features, like to assuming the IAM role kind of features, that is different, but this is high level understanding.
No, that's perfectly correct. Yeah. Thanks, Mohit. Yeah. So let me give you a simple example of that. So let's go to the IAM console. Okay. So basically, the way I have accessed this IAM console is via the username and a password. But in case of AWS, if you want to access the service, the way you are going to access it with the help of something called access key and secret key. Okay. So what exactly are those? Just a one-liner. So let's say I created this user called demo user. Okay. And here you can give an option like provide a user access to the management console. Management console means this AWS console. Okay. This AWS management console. Okay. Did I click it? Let's remove this for the time being. Okay. Now we have the option to add this user to a group. So if I want like a similar set of user to have perform a similar set of functionality, I can add it as a part of a group. Okay. Let's leave it. Create user. Okay. We have created this user, but think of it. We did not assign any permission to it. We just added to a group, but we don't know what that group is. And this basically is good for nothing, right? We did not assign any permission to it, like what this user will be able to do on AWS. And in order for this user to do something on AWS, we need to assign something called a policy. So let me show you what policy is. Policy directly. So one of the most dangerous policies is administration access, which means this user can do anything. And we normally do not assign this kind of policy to a user. The way, so for example, let's go back to our S3 case, and I want this user to only read the data or list the bucket. So I can give him S3 read only access. Okay. So I add this permission. So depending upon your use case, for example, if you want this user to do something with the EC2, I can assign EC2 level permission to this user. Sorry, yeah. Add permission, attach policy, and I can search for EC2 based policy. So EC2 full access. Similarly, you have EC2 read only access. We can give it to the user. So we have solved the two part of the puzzle. We have created the user. We have assigned what this user can do. But how this user is able to do that, and in order to do that, we need to create a key for it. So like I mentioned, if I need to log into this AWS console, I need to give a username and a password. But this does not work in case of AWS, right? In AWS, the way you access these resources is via something called a API, right? That's why the name is Amazon Web Services. You are making some kind of an API call. So even if I'm clicking on this tab, there's some API call which is happening behind the scene, right? Which is making a request on the behalf of me. So similarly, we can do something called this security credentials. Okay. And basically think of these security credentials is like a username and a password. So the way I am accessing the console is via the username and password. I can generate these keys using this, which will act as a username and a password. Okay, leave this. And this is going to create this access key and this secret access key. So again, think of this my username, and this is my password. Now, if I need to make this request to get some services, I can use this key to make those requests. So the way I do it, let me show you. I know it's getting too basic for some of you guys. Connect. This we have looked at yesterday, EC2 instance connect. Yeah. And I need to use something called AWS configure command. So here I need to define this access key ID. So here I need to choose this access key ID, the secret access key, the region name, and the output in which I want. So output can be in the format of JSON, YAML, or text. Okay. So now, what do you guys think? What will be the biggest disadvantage of this? Like, I created this key, I'm able to use it, but do you see any advantage, any security flaw using this kind of approach? So I've created a user, I've assigned a permission or a policy, I have created the key, and now using that key and mapped it with the permission, whatever I have assigned it. So let me show you again here. So I created this user, I assigned the permission, right? Permission is the S3 read only. Then we have created the key, access and secret key, which is the username and a password. And then using these key, I should be able to access this S3 bucket for this particular account. But do you see any disadvantage in following this approach? So one of the biggest disadvantage of this is that these keys are static, right? These are static keys. So if anyone will be able to hack this key, he will be able to access my account, at least the S3 part. He will be able to read my S3 bucket. So I need a mechanism through which we can generate these keys on fly. And that is where we have a service called Simple Token Service, or popularly known as STS. So what this will do, whenever I am going to make a request to this EC2, to the Simple Token Service, it is going to generate these keys, which we have generated statically. And the interval is like, you can do it for 1 hour to 12 hours. So after, let's say I set it up for 1 hour. So after every 1 hour, it is going to generate a new key for me. Okay. So now correlate this with the IAM role, which we have discussed earlier. When you create a IAM role, okay, or let me show you how to create an IAM role really quickly. So let me create it for EC2. And the same thing which we have done earlier. We can search for EC2. Let's say EC2 full access, just to give you a demo. EC2 demo IAM role and create. And let's look for this guy, EC2. So under the hood, what this is doing is that it is calling the STS service. And if you look at here you will see maximum duration 1 hour. Okay. So if I'm going to attach this IAM role to a EC2 instance, or if I'm going to assume this IAM role, it is going to generate a key for me at the backend, and it will automatically rotate those keys every 1 hour. And you have an option, if you go to the edit, you have an option to modify this duration, but it is from 1 to 12 hours. So after every 1 or 12 hours, it is going to rotate those keys for me. That's the advantage of using the IAM role, or in the backend, it is going to call the STS service. You can use STS service even from the command line to get those keys or all this information. Okay. So we have solved the second part of the puzzle. Like, okay, we have this EC2 instance, we have this Nat Gateway attached to it, and we have this S3 bucket, and we don't want everyone to call this S3 bucket. That's why we assigned this IAM policy, so that only a restricted set of users who will be able to access this S3 bucket. Okay. Now let's make this scenario a little bit complicated. My security team came and he said, okay, this architecture is perfectly fine. But the problem here that, let's say you guys are not aware of that firewall or all those things. So EC2 instance, even if it's the part of a private subnet and it has a NAT gateway attached to it, we have created it dedicatedly to access the S3 bucket. But now this has a NAT gateway attached to it. Any of the user, he will be able to access the rest of the world. So I mean, anyone who is sitting here, he will be able to access google.com or any of the like Facebook, any website. So he don't want to do that. He only wants that, okay, this EC2 instance is only been dedicated to S3 bucket. So they said, okay, the NAT gateway solution is not going to work for here, because let's assume they are not aware of all the firewall solution and everything. They said, please remove NAT gateway from this picture. And we want a secure way to connect this EC2 instance to S3 bucket. So do you guys think of any alternative solution we can implement it over here, so that we don't need a NAT gateway? We just want this EC2 instance can only talk to the S3 bucket. NAT gateway means it's you have opened the floodgate. Now this instance can talk to anything, but we just want a dedicated peering. Peering is not a correct word, but we just want a dedicatedly this EC2 instance can only talk to S3 bucket. How can we achieve that? So for that, you have something called endpoint, VPC endpoint. I can give you a simple example. Like you say, if you go to this, let's say, okay, google.com. If you go to google.com, right, you see all these different tabs: about, store, Gmail, images, whatever it is. One thing, all of you agree that these are like a dedicated tabs, right? And there may be a n number of teams who are working behind the scene, who is managing these tabs, right? There will be a dedicated team who is just working on this store part. There will be a dedicated team, not about, but at least the Gmail part or at least the images part. Now go back to our AWS example. We have this dedicated service, right? VPC, EC2, S3, all these n number of services, which AWS is providing it to us, right? From end user point of view, these are hosted in some of their data center. We don't know, but it may be hosted somewhere else. And these are all publicly accessible service, right? I am sitting over here and I will be able to click on this EC2 or light sale. Similarly, you can log into this AWS console and you will be able to access these services. Okay. And one thing you all agree, they will be hosted in some data centers, right? And similarly, the architecture we have defined earlier, that we have the dev environment, then we have the non-production environment and production environment, right? Non-prod, and then we have this prod. Okay. Maybe not. In some of the cases, we have this access to this environment, right? Like in my own data centers, now if I need to push a code from non-prod to prod, there may be a connectivity, right? So similarly, if you look at this EC2 S3, let's say they are hosted in some AWS data center, right? And these are all public facing service. So AWS should have some internal route if EC2 need to talk to the S3, or if S3 need to talk to a Lambda. And that is where this endpoint comes into play. So if I connect this EC2, let's remove Lambda to this picture. If I connect this VPC endpoint here, all the traffic from my EC2 to this S3, it will become dedicated and it will go to Amazon network backbone. So the advantage of that my traffic, my network traffic will never be exposed to internet. Okay, and it solved my purpose too. That okay, I only want this EC2 to talk to S3. Okay, so this is the advantage of endpoint. Endpoint provides that connectivity. Is that clear?
Yeah, but like what in the VPC endpoint where we need to do the setting, like where we need to do.
Let me show you. So if you go to this endpoint tab over here, go to create endpoint. Let's say give any name, my Dev@pp. Under AWS services, there's something called S. Let's go it for S3. And let me tell you the difference between the interface and gateway. But for the timing, let's assume interface is a new way how you are going to connect to that endpoint. You need to select your VPC. Let's say this my demo VPC. Select the subnet. So for example, in my case, I know that this is a private subnet which need to talk to the S3. I can select IPv4. I can assign security group. I even have the control that, okay, I can define a policy, this IAM policy. So the advantage of that is that, let me go back to the board again. Even after creating this VPC endpoint, I want that, okay, this connection if only generate from this particular VPC, or even, okay, yeah, let me repeat it again. I even have a fine-grained IAM policy where I can define, okay, if the connection generate from this particular VPC, then only allow it. Or even at the bucket policy level, you guys may be aware of this bucket policy for S3. I can say if the request is coming from this specific endpoint, I only then allow it. I can even go at that much fine-grained level. And that's it. Not a valid. Did I miss? Oh, I did not specify the custom policy. So create endpoint. Yeah, that's it, Bautik. So interface endpoint, it is in the pending state, and after a few minutes, it will be available. So the way it works, okay, let me go a little bit depth of like how this works. So we talked about all these scenario, like, okay, how this whole communication works. Let me give you a simple example. So once we have this endpoint available, the way it works is that inside your VPC, it is going to create one ENI, classic network interface. And that ENI can talk to the VPC endpoint. In our case is S3. So it's a direct communication level. It's going to insert this ENI at your VPC, and this ENI has the same IP as your VPC subnet. So now in future, if this EC2 instance is need to talk to this S3 endpoint, it's a direct one-way route. You don't need to go to all these route table, all these combinations. AWS will take care of all these things. And if you want to go into some more depth about it, under the hood, it uses something called private link. I'm a big fan of private link. If anyone wants to talk to me about private link, please feel free to ping me. The only thing which I don't like about private link is you must need to go via the NLP. If you know that AWS now release a new service called VPC Lattice, where you don't need NLP. And it works at layer 7 versus this one works at layer 4. I mean, that's a completely separate topic. But for this point of time, just understand that once we have this endpoint enabled, it's going to insert a ANI at your VPC, and then your EC2 instance can talk to this directly to this ANI and to this endpoint. So this solves our second purpose, where we want a secure route to talk to my S3 bucket.